Hello there guys, in this video I would like to talk about some important points which will play an important role in the efficiency of ductwork and what can be done to increase ductwork system efficiency. So the first thing we need to take into consideration is the material which is used for the ducts, and the roughness of material as does cause friction, which is the loss of pressure that occur in the duct due to the effect of the airflow dragging near the surface of the duct, which can cause resistance to the motion of airflow. For example, if we have two ductwork systems from different materials with equal dimensions, equal flow rate and air velocity, so the biggest difference is the material, and let's say one is made from galvanized steel and the other from fiberglass. So the pressure drop over a 40 feet distance is around 0.04 inch of water column for the galvanized steel and 0.06 inches for the fiberglass. And the second thing we need to consider is the shape of ducts, which will play a big role in the overall efficiency of the system. Ductwork comes in round, rectangular and flat oval shape. Therefore, round duct is the most energy efficient type by far. So if we compare a round duct in the example, which has a diameter of 16 inches, a parameter of 50 inches and capable of delivering 1500 CFM with an air velocity of 1100 FPM, to rectangular duct, which is an area of 18 by 12 inches, a parameter of 60 inches and capable of delivering 1500 CFM with an air velocity of 1000 FPM. As we can see the example here, the rectangular duct requires more metal for its construction, which can add more weight and cost to the design. It also has a larger parameter than the round duct that will allow more air will come into contact, which can cause friction to the system. Friction in a system can cause the fan work harder, and as a result causes higher operating costs. Therefore, always use round duct when there is no limited space, and use rectangular duct as space is tight and limited. And the third thing we have to consider is the dynamic losses caused by fittings. Can change the airflow path's direction, and these fittings include entries, exits, elbows, transitions and junctions. So we have to use the smallest fittings possible for energy efficiency. And there are also some more important points which play a big role in the overall efficiency of the system to take into consideration, is such as proper insulation, proper connections, proper balancing, proper duct supports, avoid from designing oversized system, avoid from making compressed system, avoid from designing undersized system, test and recheck the system to find the leak. Do not use too many restrictive duct fittings. Do not use too many elbows. Do not use branch ducts that are too long. Check and fixing all pinch points across the flexible duct system. Use the smallest fittings and all components such as coolant filters, blower, registers and etc. And let's say the system we design has only a loss of 1000 BTUs of heat. So if you divide 1000 BTUs of heat lost by 60,000 BTUs and times 100, that gives us 1.6% of heat loss within the system. So this means the system is around 99% efficient at base. So 1.6 of heat loss could be due to inadequate insulation or leaky in the system, such as fittings, transitions, or some resistance to the airflow. And here, as we can see from the yellow circle line in the design, the inlet airflow directly strikes the sharp turns that are present in the system, which can cause an increase in the static pressure. The sharp turns cause a large amount of recirculation region within the duct and preventing airflow from moving smoothly. And the T-section at the end of the main duct causes the air to suddenly divide and change direction, so there is a high amount of backflow here, which can again increases the static pressure and reduce the amount of air delivery. And the high velocity in the main duct, which is caused by the sharp turns and sudden bends, reduce the airflow into the branches on the left and right side of the system. So we have two standard designs. The first design is more efficient due to reducing the sharp turns than the second design, which is more sharp turns. And now if we compare the two design with this design, which has been optimized, is more efficient than the two standard designs. So that's it for today. I appreciate you for watching this video.